Pebble Graphics is a virtual reality application inspired by the educational programming language Logo, and perhaps its most well-known feature, turtle graphics. The star of Pebble Graphics is Pebbles the dog. You'll put together various programming objects to tell Pebbles how to draw what you want, all while learning foundational concepts in programming. In this video, we'll teach Pebbles how to draw a square of any size. Before we get started programming, let's go over some of the basic controls. If you look at your controllers, you'll see there are labels that tell you what each button does. If you hold down the select button using your right index finger, you'll see a solid sphere appear. You can use this sphere to select objects by touching it to the object you want to select. Let's go ahead and select the tutorial window. Now if we look at our controller, we see buttons have new labels that tell us what they do for the selected object. In this case, we can use them to go to the next and previous pages in the tutorial. To unselect objects, we press the select button in empty space. We can use the grab buttons on the sides of the controllers to move around. Simply hold down the grab button and move the controller, then release it. It's as if you're grabbing the world and pulling yourself in the direction you want to go. You can use either controller to do this. You can change how big or small you are by using both controllers and moving them closer or farther apart while holding down the grab buttons. This can be really useful for moving over longer distances quickly. You can move objects by touching the clear sphere on either controller to the object you want to move and then hold down the grab button. This grabs the object and it will now move with your controller. If you rotate your hand while grabbing an object, the object will also rotate. To stop grabbing an object, just release the grab button. Now let's start programming. The left controller has a toggle menu button. Pressing the button brings up available programming objects we can create. When the menu is open, there is a pointer on your right controller. Touch the pointer to one of the menu icons, then press the select button on the right controller to create that object. Let's create a number object and a forward object now. In a more traditional programming language, we would call the forward object a function. It tells Pebbles to go forward. The function has what's called a parameter. It's a way to change what happens when we run the function without having to change the internals of the function itself. We'll learn more about this concept later. For now, we can see the forward function has a single parameter called distance. Distance tells Pebbles how far to travel forward. We can set the value of distance by placing a number in the empty box next to it. In programming, this is called passing an argument to a function. Here we are passing the number 1 to the forward function, so we're telling Pebbles to move forward by 1 unit. Let's actually move Pebbles using the forward object. We can also call this executing the forward function. We select forward just like we selected the tutorial window earlier, but now if we look at our controller, we see some new labels. We can use the thumbstick to step forward by pressing it right. The first step is to compute the parameter. In this case, it's just the number 1, so it just computes to 1. But you can also imagine passing a mathematical expression like 2 plus 2, in which case we need to calculate the result of that, which is 4, and that value would then be used by the forward object. Now that we've stepped through the parameter computation, we step forward again to actually execute the forward object. Here we see Pebbles has moved forward. One of the interesting features of Pebble Graphics is the visualization of both execution and change of state. When we step through a computation, we can see those steps as a visual history in the third dimension. In the case of forward, we see here the first step, which is the execution of the number 1, and the second step, which is the execution of forward itself. In programming, there's a concept called state, which you can think of as a snapshot of the world. Another way to think about it is as all the data values in the world at a particular moment. So for our environment, part of the state would be the position and angle of Pebbles the dog. Pebble Graphics visualizes changes of state. You can see that here where the green line and the little dog marker show the state, in other words, the position and angle of Pebbles before forward is executed. Another interesting feature of Pebble Graphics is you can not only see and step forward through the execution of a program, but you can also step backward and reverse the computation. To step backward, we select the program, in our case the forward object, and we see the step backward label on the left side of the thumbstick. We press the thumbstick to the left, and that undoes the execution of forward. And we see Pebbles has moved backward, and the line she drew is gone. If we press the thumbstick to the left again, we reverse the execution of the distance parameter, and now we're back to where we started. What if we don't want to go through every step of a program to see what it does? Pebble Graphics also has a run mode, which goes through all the steps automatically. To switch to run mode, we unselect all objects and note the button on the right controller now says switch to run mode. Press it to switch to run mode. Notice the history of forward disappears. Every time we switch modes, this will happen. Now when we select the forward object, the only thumbstick option is to run the program. We press the thumbstick to the right and we see Pebbles has moved forward. It's also worth noting the visual history of each step in the execution, and the change of state is now gone, and instead we just see the result of the computation. In this case, there isn't really a result, so we just see a sphere. But in the case of something like 2 plus 2, the result of 4 would appear. Another thing to remember is in run mode, you can no longer reverse the computation. We just got Pebbles to move forward. Now let's get her to turn. We create a rotate object and a number object. We can change the value of the number by using the editor. Select the number and look at the left controller. There is a label to open the editor. Press it and use the keypad to change the number to 90. Now we pass 90 to the rotate object's angle parameter. Step through the execution and see that it does indeed turn Pebbles 90 degrees. We also see that the angle of Pebbles, or the state before the turn, as part of the visualization. We can execute forward and rotate individually, but it'd be nice to put them together into a single program. Luckily, we have what's called a sequence object that does just that. Let's create a sequence object using the menu, and notice that it has a handle that can be pulled up and down to set the number of containers in the sequence. For our purposes, we need 2. We'll put forward in the first and rotate in the second. Now let's step through the execution of the sequence object. After the first step, notice that forward executes all of its steps completely. In general, each step of the sequence fully executes whatever is in the container for that step. But what if you want to manually step through an object of the sequence? If we step back and look at our controller, we can use the thumbstick to step in. This will move control of execution to the next subobject, in this case, the first object of the sequence. Now if we step forward, we step through execution of the individual forward object instead of the whole sequence. If we switch to run mode and run the sequence, we can now move and turn with a single press of the thumbstick. If we do this 4 times, we get a square. What if we want to draw a square with a single press? We could create a new sequence object of size 4 with each container having a copy of the move and turn sequence. But that's a lot of objects. Luckily, we have a special object for running a program over and over again. Let's clear the screen by running the clear screen object, and we'll learn how to use the repeat object. Let's create a repeat object, and we see that it has 2 parameters. The first is count, which says how many times to repeat, and the second is compute, which tells what computation should be repeated. We'll create and pass a number 4 for count, and for compute, we'll use the move and turn sequence. If we step forward, we see the count parameter is the first thing executed. Then the next 4 steps execute our move and turn sequence. The last step just shows we are finished executing the repeat object, which is indicated by the solid sphere. Most programming languages have something similar to the repeat object. They are often called loops, since you run a piece of code, then loop back around to do it again. We've seen objects like forward and rotate, but what if we want to create one of our own? We can do this using the symbol table. The symbol table consists of 2 columns. On the left side, we have symbols, and on the right side, we can assign values to those symbols. We'll get into what that means in a second. For now, let's edit the existing symbol and rename it to square using the editor. This time we have a keyboard instead of a keypad. Now we can put our repeat program into the container next to square. This is what we mean by assigning the value to a symbol. We can create an instance of the symbol by touching a controller to it and pressing the grab button. Something like symbols are also known as variables in typical programming languages. What happens when we execute a symbol? The first step is what we'll call a substitution. Here we see the symbol is replaced by the value it's mapped to in the table, in our case, the repeat object. The next step executes that value. If we switch to run mode, we can now draw a square with a single press of the thumbstick. And we have an object that has a clear name for what it does. Another way to assign a value to a symbol is using the set object. Let's add a new symbol to the table by pulling the handle down and create a set object. The set object has 2 parameters. The first is a symbol from the symbol table, and the second is the value to assign to the symbol. Let's pass set an instance of our new symbol for the first parameter, and we'll create a number for the second. Now the first step of executing set computes the value parameter, and the second step updates the table with the result of the value parameter. It's worth noting we wouldn't have been able to define square using the set object, since set assigns the result of computing the value parameter, and for the case of repeat, there is no result. Set works this way so we can do things like set a symbol to increment itself, like x equals x plus 1. Getting into the details of this and how you could change the system to use set to define square are beyond the scope of this video. We've created our own square object that draws a square with side of length 1. But what if we want to draw squares with side of length 2 or 3? Instead of creating new symbols for each type of square, we can instead change square to have a parameter for side length. Let's clean up our workspace by switching to run mode and deleting some of the objects in the world. In order to add a parameter to a symbol, we select the box next to the symbol in the table. This gives us the option to add parameters using our right controller. Once we've added parameters to our square symbol, we can rename the parameter side. Now we'll want to replace the 1 we passed to our forward command with an instance of the side symbol. When we create an instance of square, we see it can take a parameter. Let's assign the number 1 to the parameter and run it to draw a square of size 1. Now edit the number to something else and run it again, and we see we can draw a square of a different size. The process of replacing part of a program with a parameter is called abstraction, and in some ways it's the heart of computation. In fact, there's a tiny language called the Lambda calculus that consists of only 3 rules based on creating abstractions and substituting values into those abstractions. And with this system, you can compute anything that can be computed. We won't go into anything deeper than that, but it suffices to say you've just learned a very powerful concept in computing. And now you're ready to make your own programs. Congratulations on finishing the video, and welcome to the Pebbleverse.